Hello and welcome to Orders of Magnitude, a very applied lesson in physics. Let's start by this beautiful elephant. I put it on a weighting scale and I measured the mass. Suppose that based on the measurement, the mass of this elephant is 3,827 kilograms. Then I draw a number line and I try to find two consecutive powers of 10 which can embrace this number. You can easily guess that this number lies in between 1,000 and 10,000. Okay, 3,827 could be somewhere like this. Okay, if I compare, I see that, yeah, this number is closer to 1,000 than 10,000. So forget about 10,000. I think 1,000 is a good representative for this number. So I take 1,000 as my representative and I try to write it in powers of 10. Yeah, it's 10 to 3. And let's take the 3 to be order of magnitude of this number. What happened? I found an estimate version of this number in powers of 10, and then I got the power of 10 as the order of magnitude, the exponent. Good. So exponent of estimate version of the number in powers of 10 is the order of magnitude. That's all. So for a given number like that, I can set some powers of 10 and take the estimate version of that as a power of 10 and then report the exponent of 10 as the order of magnitude. But for now, I recommend to learn a scientific notation and then continue. It's really important for finding the order of magnitude. Scientific notation is very easy to learn. Suppose that a given number is like that. Then you can by default put a decimal point here and then write it as 2.43 10 to 2. So 243 is also 2.43 10 to 2. But it's scientific notation. It has its standard format. Why? Because it has a coefficient which is a number always between 1 and 10. It has a base which is a 10 and also a 2 as exponent. 2 also could be negative. So exponent is always an integer, but it also could be negative. For any given number, you can do this process and find the scientific notation. Look at this number. The coefficient here is very important because coefficient is always a number between 1 and 10. So let's take the number line and put 1 here and 10 here, and also a mid station like that, 5. Okay? Let's establish a rule. The rule says if I have a number between 5 and 10, it could be rounded up to 10. So if the coefficient is a number between 5 and 10, it is estimated or substituted for 10. Otherwise, it could be a number between 1 and 5, but smaller than 5. So it's rounded down to 1. Let's try this number. I have a number and I have already converted that to scientific notation. So the first process is that all the given numbers must be converted to scientific notation and then you start the process. Okay, temporarily forget about 10 to 3. Suppose that I just concentrate on the coefficient. Coefficient is 3.820. It's a number between 1 and 5. As it is smaller than 5, so it can easily be estimated by 1. So 1 times 10 to 3 will be 10 to 3. So 3 is my order of magnitude. That's it. The other number could be 7.593 10 to 3. How should I find the order of magnitude? It has already been a number and I've converted that to scientific notation. Okay. Temporarily forget about 10 to 3 and just concentrate on the coefficient. The coefficient is a number between 5 and 10. As it is greater than 5, so I can easily estimate that by 10. So the representative for 7.593 is 10. 10 times 10 to 3 will be 10 to 4. I take 4 as the order of magnitude. You know that the exponent is taken as the order of magnitude. Let's have more examples. Suppose that the given number is 4.7 times 10 to negative 9. Temporarily forget about 10 to negative 9 and just concentrate on 4.7. 4.7 is a number between 1 and 5 but smaller than 5, so it is estimated by 1. 1 times 10 to negative 9 will be 10 to negative 9. Negative 9 is my order of magnitude. So the order of magnitude could also be negative, yes. Another example could be 8.3 10 to negative 18. It has the standard scientific notation for math, so it's okay. Temporarily forget about 10 to negative 18, and then 8.3 is the exponent, a number between 5 and 10. As it is greater than 5, it's estimated by 10. So 10 times 10 to negative 18 will be 10 to negative 17. So negative 17 is my order of magnitude. How to compare orders of magnitude? Suppose that estimation of human mass is 10 to 2 kilogram and that of an ant is 10 to negative 3 kilogram. Compare these two masses. Okay, for comparing the two masses, I can divide them. I can write 10 to 2 over 10 to negative 3 and find 10 to 5. And I can say a human is 5 orders of magnitude or 5 powers of 10 heavier than an ant. You could also take a direct approach like that. Subtract 2 and negative 3. 2 minus negative 3 will be 5. So again, a human is 5 orders of magnitude heavier than an ant. And this is the comparison. If you enjoyed, do not forget to subscribe and give a like. See you in more videos.